Okay, so last year, the last 2 years, I think I presented on the test suite. So most people, I think, are already familiar with it. I will do a brief recap. This presentation, I'm going to be talking about the test suite for process modeling components. There is only one test suite. It currently only works with process modeling components, but it will be extended to work with process modeling environments as well, which is the next presentation. So I'm going to start with a demo in this an unusual way. So we'll get that out of the way. Then I'm going to give you a brief update on progress, talk about the vendor feedback we've had so far, talk about the next steps for the rest of this year and next year, and then 3 almost background information and requests for discussion, either at the end of this presentation or over lunch or in the breaks or whenever. And that will cover the process we use in developing the tests and how we test the test suite. And we have a category of tests called best practice. What are they? How do we develop them? And if we've got time at the end, questions, feedback, but obviously we're all going to be around for the next day and a half, so there will be a chance for discussions offline as well. So without further ado, very quick reminder of the test suite architecture that has been developed for testing PMCs. Thanks to Jasper for packing this diagram together for me last week. So we have developed the test engine, this bit in the middle here, which is bespoke code, developed and maintained for CO-LaN. The end users will never need to see that. That is maintained and is a black box. We have the test engine creates the test context, which is where we create, deposit, etc., the component that is under test. So this is a separate component within the test engine that then creates the component under test at runtime and does all the interactions with it. So that is one set of code that is fixed and will not change. We can then add tests to it. So the tests are independent from the test engine. So we have test categories, which the demo will show to you, and the test categories contain tests. So we can implement tests separately from the test engine itself. They're still in code, but they are developed separately. And in principle, the ability is there for the end user to write their own tests. Then we provide 2 interfaces to the test engine, the command line interface. The Open Test Suite command line interface is what that little acronym means. And we have a G-test interface. I'm going to demo the command line interface. So, and the test engine produces the reports. I'm pointing at the screen, use my mouse. The test engine produces the test suite reports, which are in a format that is both machine readable and human readable. They're a JSON format, which the format of which will be published, so you can do anything you like with it. It is human readable and machine readable. So that's the architecture. So what we currently have is a partial implementation of the compliance tests for property packages. That's as far as we've got so far. Out of there, minimize that. Hopefully this is showing on the screen. So the first thing you do, find the Cape Open test suite folders, and we have a 32-bit and a 64-bit version. The difference between them is the 32-bit version is used for testing 32-bit components. The 64-bit version is used for testing 64-bit version. So you install if you've got 32-bit components you want to test, and you've got 64-bit components you want to test, you install both of them. And you can install both of them on the same machine, which is what I've got here. So I am going to use the 64-bit version. And all it does, this is the command line interface. It opens a command prompt. So it sets everything up so it now knows where the test suite is, so you don't need to do anything more than that. But I do need, and the reason I've got this nice text file behind me is so I don't remember what the commands are. I can just cut and paste. So we will first off switch to the folder that I want to run in. So I'm now sat here, and we obviously have help. Is that screen keeping up with me? It is. Because we're going out to somewhere on the Teams server and coming back again. So we have online help. So you can see what the commands are. It also gives some guidance on usage. It may go up slightly. So there you actually get the sort of sequence of commands that you might need to run. I'm just going to go through now. Now, what I will say is this demo is very similar to the demo I gave last year. But there were some very significant changes. So if I do version, you should be able to see that we are now running version 0.2.2.0. So this is still a pre-release version. We haven't got to version 1 yet, still a beta test. But we have moved on from where we were last year, and I think we were on 0.1 last year.
2.1.0, 0.2.1.0.
So let us have a look at the test categories that we've got implemented. So we have, sorry, this is a test line. That architecture diagram didn't say we also have test libraries. We have test libraries that contain test categories that contain tests. And this is listing the test libraries. So we have libraries for property packages, which is the compliance tests. We have libraries for a library for the property package best practice, which contains, I think it's just 2 tests, which are not validated by the Thermo SIG. They are just there as placeholders. And we have a library for unit operation, which is just, again, just a placeholder with a single test in it, just to make sure that you can do something with the unit operation until we develop the tests. Then if I look at, drill down, and you can see the test categories that each test library contains. So here we have, and the test categories correspond to specification documents. Got that right, Jasper?
The test categories correspond to interface.
Interfaces,
but
that was my other alternative answer. Yes.
Corresponds in
So each test category corresponds to an interface defined in the specification. So we have a test category there for IP identification, which is maintained by the methods and tools SIG, and the specification document exists. The specification document for that interface exists, and this implements all the tests, testing implementations based on that specification. We have also got thermo compounds, thermo material context, thermo phases, and thermo universal principles. So we've got those 4 specific thermo property package interfaces. All the tests have been written, they've been validated by the Thermo SIG, and they are now available.
I suppose. Me too.
And if I do the same command for property package best practice, this is where we'll see those placeholder categories, which themselves contain tests. And the unit operation, we should just have 1 column. I think it's OK identification, isn't it? Oh no, we've got an OK unit there as well. So we have libraries, we have test libraries, we have test categories. So how do we actually use this? And I will say, when I said there are some significant changes, that availability of those test categories is one of the two biggest changes we've made to this system since last year. So this is the other one. We used to have a very complex gen command. It's not just called new. Yep, and it popped up the nice simple GUI where we can immediately see. Oh, to change that before I forget. Press return. So
Does the ID is, I think, automatically created now.
the test configuration ID is automatically created, but I've overwritten it with something more simple, something simpler, more obvious. And then I then press the return key, which I should have done. So here we can see exactly what property package. So we can change between those test categories, right, between the test libraries. And when you change, you immediately see which test categories it contains. I'm going to use the property package. And I am going to select T. And all the 64-bit property packages on this machine should come up in that list. And I'm going to choose alkanes. No configuration of the. I don't want to. I could go into the actual process building component and configure it. And if any of these require a temperature or a pressure or both or anything like that, I can configure the test category as well with temperature and pressure. But none of these need that. So that's all I need to do. And if I now switch to that window, yeah, config.txt has now appeared in that window. And then, so new has opened it. I can now, there is an edit command as well, so I can go back and edit that saving, but I'm not going to do that in the interest of time. And if I then run, load of information scrolled across the screen, and some very verbose error messages, which are under review. So that's immediately one of the vendor feedbacks. The messages are too verbose and not understandable always. They've got to be simplified. So that has also created me and I'll show you, rather than going through on the screen, you duplicate on the screen, but I can immediately show you there. So the report contains information about what I've just done, what I've just tested, and the report from all 72 tests. And most of those pass. There is one there that has exceeded, but there is some info. It just says testing wasn't actually performed. There's no compound constant was available. There is an actual error. So get compound constant was called with an invalid physical property, but that succeeded. It should have failed. So that is an actual error in the implementation. I believe that was there last year and it's been fixed.
Okay.
Yeah, I'm deliberately running the old version of Coco here. So I still got the errors that were there last year. So I can show you some errors. Yes, but fix them within hours. So got more info messages, got the test that succeeded, and so on. I go right to the bottom. There's another failure there. So you've got a complete report that is in a standard. That's a JSON file, which is in a standard format. We would publish that format, and off you go. So that's the basic test engine, as in test suite as it now stands. And in the interest of time, I'm just going to switch back to my presentation.
You have plenty of time.
I have plenty of time to that.
Malcolm, to be clear, you're not running any of the thermal. You're just testing out the interfaces
Yes.
that have been implemented that could ultimately use.
You are
running thermal. Okay, you are making computation calculations if you need of this and that. Okay. Compound, constant, temperature dependent. Compound.
So at the moment, all those test categories, sorry, misunderstood the question. At the moment, all we're doing is obtaining data. So we're not running any calculations because we haven't implemented thermo.
No, but you are running for temperature dependent physical property of a compound. There you are asking for a given temperature. What is this value? So something is calculated within the property package using the model in the property package for this temperature dependent physical property.
Interesting question then, because where do I configure the temperature?
You could have done so because maybe the default value of 298, okay, which is, I guess, in there for some of the configuration of the ICAP thermal compound category. Right, Jasper?
Yes, you have to use your add command there.
And it's where, in fact, this has to be mentioned, I guess, to users, because I guess KBC had an issue at some point, I guess, with not, in fact, having the right temperature used.
Yeah, but
You could have used the temperature.
if you go to the compound, thermal compounds testing, you should be able to say that's the temperature that is tested. Or what does it say? How many?
Edit not.
Depending on this test category.
But which category is temperature? Is that?
Okay, thermo compounds. Lord. I've selected it, configure test category. It looks like we might have a bug here. I didn't know I was configuring any temperatures because when I did that,
So
I
this
just
explains why KBC was not able to.
yes. I think we have a bug.
We have a configuration file.
Okay, and in the configuration, well, they did. Well, they did.
The configuration data of that same test is stored in the configuration file, so you can add.
So if I go back to,
You have to open the configuration file.
yes, so if I go to there and I open that.
I could have reported that, Richard. Okay.
So yes, it's all in there.
That configurator. You're now looking at the property package configuration.
So there should be another file in there, in the 64-bit.
No. This is the file.
No, it should
But
be
it's
this file.
either very close to the end of the document or very close to the top. I don't guess it's very close to the end.
At the end.
No, at the very beginning, you had the valid temperature values.
Oh yes, okay.
Okay, so it's these ones which are, it's at the very top. So there is not 298, sorry, it's 300.
So there's a whole array of default
Yeah.
there, 300 or 600.
Yes.
The test succeeds at any condition.
So we should configure in the temperature and pressure. For these
There should be a
properties,
dialogue,
I'm doing
but
the
the dialogues
calculations.
were a subject of discussion still.
Yes,
with
yeah.
platform mainstream.
Yes, so I will come back to that.
There should be ticket open.
Yes. All of these things.
This is a live.
I rely on my experts over here. I just try and manage. Okay, let's go back to the presentation. Okay, so a very brief update on the progress of what I've just shown you. So we have in the property package compliance tests, in those 5 categories, we have 72 documented and agreed tests. So they have been documented and agreed with ICAP identification, with the MT SIG, and for the other 4 with the thermal SIG. And that has required very significant SIGs. I'll come back to that later. Now, this is a partial coverage for compliance tests for property packages. And I'm estimating around about 50% under that order. We've got 2 more interfaces to do, but they are the biggest interfaces. So we're probably about 50% of the way through.
Typically, the ICAP thermal property routine list of tests nowadays has 20 tests. which well defined. It doesn't mean that in the end, we will have actually 20 tests. It will be more, less, but it is range numbers.
I also have a remark on that, but I will wait until you.
Now, there is a comment here that you can't test a property package that has no compounds or no phases. So if you're an end user of simulation software, this will never happen because that doesn't make sense. But if you're a developer and you're developing as you develop your property package, you are testing, you've got to be careful about which tests you run. Because if you run some of them too early, this test suite will just say you can't test if you haven't implemented compounds or phases yet. So this is a thing around how you use the test suite in the development process.
You will have to address the question by Olaf from Sandef about homogeneity of the results and so on, but I guess it is in your presentation about the validity of the values.
We'll come back to it then. Yeah, okay. The other thing we have done since last year is on the test suite engine itself, a large number of open tickets have been addressed. These were both small defects that we found, but some significant enhancements and usability since last year. So we have made a significant progress, especially around that command line interface. We've simplified the commands, made it easy to use. So we've already had some feedback from vendors on this 0.2.2.0, and they fall into three categories. So in some cases, the vendors have agreed that they need to make changes, and we run the test suite. There have been questions about the standard itself, and there have been issues and requests relating to the test suite software and the implemented tests. Go into in more detail. Is that email address?
Not yet.
Not yet. It will be valid. So, as a quick aside, if a vendor wants to provide feedback on the test suite, they send an email. And currently to the interoperability SIG leader, but we're setting up an email address so that we can change who it gets sent to very easily without having to change the email address. Okay, so proof of the test suite concept. Vendors have already, the vendors who have run it have already identified things that need to be modified in their implementations. Things like misinterpretations of the standard. And most of them, I have to say, are in areas of their interfaces that have never previously been exercised because no PME has ever done it. Because obviously you would have found those. If a PME exercised it and there's a mismatch between the two sides, you'd have a problem. So we are doing more complete coverage of the standard as implemented in the property packages. And I've listed three there. I'm not going to go through those in detail. So, but yeah, things in get a compound constant, get universal constant list, get universal constant, and it's around about how the system behaves in the more, I would almost call it esoteric ways of calling those methods. But in all those cases, the vendor has said, yep, we haven't implemented as per the standard, we will make a modification. So that really is proving the test suite, when we get there, it does actually work, doing its job. Challenges to the Cape Open standard. This is an interesting one. This is the example that's come up. ICAPE identification, put component name, put component description. The specification says that the PMC must implement the ability, and that's any PMC, not just property packages, must implement the ability for the component to be renamed. And there's been an immediate challenge on that. Is that actually a valid requirement for property packages? Must a property package be able to be renamed? And it's also been challenged whether that's always a requirement for unit operations as well. So By running the test suite and identifying what the standard actually said, we are identifying areas where we need to revisit the standard and maybe publish errata and clarifications. And what will happen if there is one of these challenges from the vendor when they run the test suite is it will be passed back to the relevant SIG. So it will come to me currently. I will review it. I'll say, well, you're actually challenging the standard, and I'll pass it to the SIG that maintains that interface specification of that interface. So we're identifying things that need to be changed in vendor software. We're identifying things that may well need to be changed in the standard, the specification of the standard itself. And the third area is things that requests around the test suite and the tests themselves. And you may have noticed when I flicked through that report on the example I just run, there were some things where it said success and gave an error message. And one typical one there is you've got a failure in one test, which means you can't run another test because the other one has failed. But we report the subsequent, the other test. They may not be subsequent, it may go into either order. But because you can't finish a test, the error gets reported that says we haven't finished this test because there is an error in another test. But it's flagged as successful, which might be seen as a little bit of an oddity. You haven't completed the test because there's an error somewhere else. Was that test that you haven't completed successful or not? And we need to review this one. The developers need to review what's happening here as to whether it's reported as a failure, a success, or skipped. And I gather there are problems with the way something like G-test works as whether you can even do that. So we need to revisit that one. But we will do that. We're not going to ask any questions about that. The question's been asked about simultaneous testing and logging. So can you run the tests and at the same time see exactly what information was passed backwards and forwards? So we could extend the test suite to do that, but we're then duplicating the functionality of code. So you can run the test suite and code simultaneously. You can put code into this system, so it sits between the test suite and the component under test, and get the code report for a common component. But you then get an incredibly verbose report. So I think there's some work to be done here as to whether we can automatically both code test suites, so you get to set both of them up, and whether we can actually control the amount of information we get from the test suite and code. And code doesn't work with Cobia. Something else has got to be done to allow logging of Cobia.
That's on the plan for Cobia.
And yeah. So that's going to have to be handled by the Cobia project rather than the test suite project. But there are some things we need to look at to see whether we can do that without duplicating the functionality of what will be available in Cold and in Cobia in the test suite, which is the last thing we want to do. Request for an extended GUI so that you can control everything from the GUI. It becomes a true graphical user interface rather than a series of drop downs. And you could actually select the tests and see the reports of the tests from the GUI and things like that. Make it much easier to use. I suppose one of the questions there is what is the end user community for this? If it's only ever used by developers and very experienced process simulation users, do you need a more visual extended GUI? And our current philosophy is to develop a minimal interface that is usable. Because otherwise our development and maintenance overheads are going to go up significantly. GUIs are expensive things.
There's actually two sides to that story. One is if you're a developer, your IDE typically provides a UI for testing, so it's already there for most developers. And the other side of the story is that there's some synergy there to be obtained if we go into Cobia and automatic marshalling from Cobia interfaces to COM interfaces, because the test suite exposes Cobia interfaces. to test that, we might very well want to set up a .NET, little .NET project just to exercise those interfaces. And then we might as well put that to work as a test for we.
And moving on from that, the final one is validity testing. Do we actually test the values that are being returned by the property package? We don't. We just make sure that a property is a positive real number. We don't actually test the value. And checking the validity, checking that the values of property package return doesn't change from one version to the next or changes in an acceptable way is very important to an end user. But it's what we decided 30 years ago that Cape Open was not about. Cape Open is about interfaces by those values, not checking the values. So is checking the validity part of the remit of CO-LaN? Or could we actually do this by allowing user-defined tests?
No, I was trying to show what Olaf Bergling at Syntef was asking in this category. Could you read the question if we can?
What Florence is looking that up. What we could do is provide user-defined tests, which allows you to run across a complete series of values, inputs, so that end users could write their own tests and they can check the validity. Completely independent from CO-LaN, we're just providing the functionality to do it really quickly and easily within the test suite by you writing your own tests.
Malcolm, can you read the question by Olaf?
Do the tester include testing the consistency of properties? The answer is no, it doesn't currently. And I am challenging whether it's part of our development effort to do it, because I think it's very specific to each individual end user as to what they want to test. But can we provide the functionality that the end users can write their own tests, which do whatever they want to do? So a halfway house, provide the functionality but not write the tests.
Doesn't every developer already have a set of tests, regression tests, unit tests, and so on? So this seems to me to be not the job of CO-LaN.
I would agree, and every operating company, for example, will have a set of regression tests before they accept. But can we facilitate doing that regression testing by providing user-defined tests that allow that sort of thing to be done, so we can actually facilitate the regression testing of Cape Open interfaces with actual numbers. Sorry, no, rephrase that. We can actually do regression testing on the values provided by Cape Open components, irrespective of whether the interfaces work or not. Because what we're doing here is testing the interfaces, not the values. But can we provide the functionality that allows anyone, a developer, an end user, to actually generate the values so they can test the values?
Well, my personal opinion is that there are far more important things to be done rather than trying to provide this
Okay.
facility.
Let's come back to it at the end. It's a question on my last slide. Let's come back to it. Let me get through the presentation. Okay, so what are we going to be doing this rest of this year and next year? This year, we are going to be documenting it and implementing the remaining tests for compliance of property packages, which is IK Thermo Property Routine and IK Thermo Equilibrium Routine. So that is planned to be finished by the end of the year, so we have 100% coverage of property package compliance. And that is when we will release version 1.0 of the test suite. We will be doing documentation, so you have full documentation on how to use that command line driver, how to interact with it, so you can automate that JSON schema, so you can repackage the information coming out in the results file in any way you like. and making sure the design documentation is up to date and consistent. And there are a handful of remaining open tickets that we require for property package, and we will also address those. And for 2024, we will move on to unit PMC compliance tests. Holy ballgame. And we will continue to review vendor feedback. So there will be an ongoing thing that if a vendor feeds back, we will review that. One thing that might happen is the vendor comes back and says, oh, I've got a failure here. I think it's a problem with the test suite, or it's a problem with the standard. And we review it and say, no, it's a problem with the vendor implementation. So we've got to have that effort to actually work out where the issue actually lies and who needs to do something about it. And that will be ongoing in 2024 because we will release the test suite into the wild, available to all CO-LaN members. So that's the plan for the rest of this year and next. It's taken us 18 months to get those tests to where we are now. Property package tests, 72 of them. It's taken us about 18 months to document and implement them. Why does it take so long? We have a generic process. So the first step is there's a data extraction phase by Michelle, which produces a list of the tests required for an interface and gives the rationale behind those tests. If Michelle raises any questions around the actual specification of the interface, it goes back to the relevant SIG for review, discussion, and may result in an errata and clarification to the specification. When that step is finished, it then gets passed to our software development resource, Marcus Bruno, over in Brazil, in particular, who converts that initial list into a formal test specification. And you can see if this works. There it goes. Open document for me. Come on.
It is working, yes.
Okay, finally. So this is a test. This is a test specification for Thermo phases. And I'm going to scroll through it quickly. So there is a lot of background information around compliance tests in all these documents, and gives some background requirements for implementations. But then we actually get, I'll go straight through all that, then we get through into each individual test. And I'm going to go to get done phases, the function of get done phases. Basically, this test verifies the get done phases are implemented. But you can even see there's a rationale there. It talks about errata and clarifications. And if I now go to, so execution, step 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 steps in the test. And most of those could actually produce an error message, a different error message from each one. So that is, it sounds a very simple test, but the actual test specification is complex and the test implementation is complex. None of these are simple to make sure you tested completely. That's all I wanted to give you a flavour of how long, and that's not a complex one, Jesper tells me.
No, that's a very simple test.
Even that has got 10 steps in it. So once the formal test specification has been developed by Marcus, it then goes back to the SIG for review. And there may be, if Marcus has raised some issues, there may be additional errata and clarifications required. And after that step, the tests are implemented, code is reviewed. So there is a lot of backwards and forwards in this process. We have discussed speeding it up, and we've come to the conclusion it is very difficult to do so. I do have a significant question here as to what happens when Michelle retires next year. Because, as you may have noticed, Michelle is rather an important step in this process.
No, it is the CTO.
It is, oh, no, it's the CTO. But can your successor do this job? Question. Or is it Michelle? Is it Michelle acting currently as the CTO who is required to do this job? That's a question for me. How do we test the test suite? We currently do it with code review. So, for example, Jasper reviews the code that Marcus has written. We test against the available implementations that CO-LaN has, providing CO-LaN, providing PMCs and available third-party licensed PMCs. So we should be doing that testing. And we get feedback from vendors. So we may get test failures come back from a vendor that they don't think is correct. So therefore we've got to look at the coding, test specification and the coding. And we either fix the test or we pass it straight back to the vendors. We say, well, actually, we think it's a problem with your software, the implementation issue with your software. Is that level of quality assurance sufficient? And my worry is if there is a false failure, we're going to find it. Because a vendor will test, they'll say, we've got a failure here which is not correct. And pass it back to us, and we'll say, okay, yeah, we agree, the test has not been implemented correctly, we need to make a modification. But if we have a false success, i.e. something passes the test, but it actually should have failed because of a problem with the test specification or its implementation, we're never going to detect that until somebody tries to use that component in a PME and it fails. So I have a worry that that testing process won't detect false successes. But how big an issue is it? It's the very fact we have interoperability mean that they don't exist, or they're very few and far between. Come back to that in a second. And my final thoughts on best practice tests. We're currently focusing on compliance tests, not best practice. But there's always been an intent to include best practice that's not specified by the standard as such, but is known good practices for implementation. I have some questions here which have come up during our development process and our discussions. What actually is best practice? Is there an agreement between us all on what is best practice? Who is responsible for defining what is best practice? Is it the SIG? And we have a wide community of Cape Open users, but each SIG is quite limited in the membership. So if you put it down to the SIG, is that SIG community representative enough? Or do we need to go to the wider CO-LaN community? And is it actually worth the effort? We could be getting into very grey areas where we say this is a best practice, but somebody else says, no, it's not. So for me, developing best practice tests is going to be, we need to have a discussion around it. And I think that brings me to the end of my presentation.